All right, 6.5 is actually, in my mind, a little bit easier than some of the other sections, especially, I know 6.3 is a little tough. But these are factoring binomials and really factoring the difference of two squares. So off to the side, again, I included I call it kind of my square root chart. Just you're looking for these perfect squares, okay, and what these perfect squares are equal to. Let me show you one of the slides on the PowerPoint. And again, you're looking for, you have a difference of two squares. The key is that difference. Difference means subtraction, okay? So you're gonna have two squares, square roots separated by a subtraction sign, all right? And this is basically, when you do have that, when you have two perfect squares on each side, each number, and then a minus side in the front, all you do is you square root those numbers. And basically it'll be, one will be positive, one will be negative. You'll notice there's not a middle term, because when you have a positive and then a negative, remember that middle term would cancel itself out. Okay, so if you look at this example here, you have, this is actually a perfect square, right? We determined that 1 is a perfect square, and we know 9 is a perfect square, and we have a subtraction sign in between. So it's just gonna be x plus 3, x minus 3. Okay, and if we had a number here that was a perfect square, that would be the coefficient in here as well. All right, so let's look at some examples. X squared, similar to that one I just showed you, x squared minus 81. So again, we know 1 is a perfect square, and we know 81 is also a perfect square, and we have a minus, and that is the key, because they're going to give you a couple that have a positive here, and that you don't have anything. You have to have perfect square, and a subtraction here, difference. Okay, remember, subtracting the two perfect squares. So again, this is just going to be x plus 9, x minus 9. Again, and it technically we'd have a 1 in front, because we know the square root of 1 is 1, but we don't include ones. So that's all you got to do there. Let's look at, and really on the assignment, they throw a lot of different ones. So I'm going to actually have a lot of examples for you. But you should be able to catch on to this pretty quickly. Again, this is a perfect square, and the 1 is a perfect square. So what's the square root of 25x? Would just be 5x. And again, square root of 1 is 1. And it's just 1's a plus, 1's a minus when you factor it. Because again, when we distribute, if we distribute it all the way out, that middle term would cancel out. That's why you do not see a middle term there. So again, perfect square, and a subtraction, that is the key. So you look at this example here. The reason why the answer to this is prime is because, yes, we have that perfect square here, we have that perfect squared here, but what do you notice in the middle? It's a plus sign. That is not you need to have a subtraction sign. If you don't have that, you cannot factor this. So we call this a prime. You will not be able to factor that. And one thing I probably should have mentioned, I kind of forget it every time, but the first thing you want to do is factor out your greatest common factor if you can. In these first few examples, we couldn't factor anything out. But hopefully you recognize on number 5, okay, that we have x's in common. Okay, so before we really do much, we want to factor out that GCF, and how many x's can I factor out? I can factor out as many as that smallest amount, right? Remember that? So I could factor out x to the 4th. And what am I going to have when I do that? I'm going to have x to the 4th minus 1. Okay, but we got to keep going, because this we can factor as well, because I have perfect square, right? We have 1 in both spots, but they're still a perfect square. And I can factor that x to the 4th. And don't forget, you're going to move that x to the 4th, originally out in the front down. And this will factor to x squared plus 1, x squared minus 1. Okay, so you see that? So that's x to the fourth is 2 and 2, and then we have our 1s and 1s. Okay, but again, we're not done because I can continue to factor this one as well. Okay, any ones with a plus, so the x to the fourth comes down. The x squared plus 1, I can't factor that one because it has a plus, but that minus can continue to be factored, and that would be x plus 1, x minus 1. So that one, there's quite a few steps. You just got to kind of keep going until you can factor. Anytime really you have a fourth or a squared, you got to kind of probably going to have to keep going on that. Let's do another example, one similar to that. All right, so with this negative 256, it is not on my chart. I didn't go that far down, but you can always check these. You put 256 in your calculator, hit the square root button, and you'll get 16. Okay, so that is a perfect square as well. But even before I start doing that, we have x's in both sides. So I've got to factor. I can factor out x to the third, or 3 x's. And what is that going to leave me? X to the fourth minus 256. So again, this is going to be one of these similar to this, okay, because I already see that x to the fourth. All right, so I can't do anything with the x to the third. That stays there. Since we know we determined that is 16, so we're going to rewrite this as x squared plus 16 and x squared minus 16. Remember I said the one with a plus we can't factor, that's prime, but we can factor this one. Okay, so you just got to remember to move what you've already factored down. Don't forget about them in your answer. And then x squared minus 16 becomes x plus 4, because square root of 16 we know is 4. So we're going to have x plus 4, x minus 4. So again, this is your whole answer, x to the third, x squared plus 16, x plus 4, x minus 4. Another type of problem you're going to see, 18r squared minus 8. Again, it's important, especially when you have an even and an even, that we look to see what factor out your greatest common factor before you start doing anything. So in other words, I'm going to factor out 2 goes into both of those, and I'm going to get 9r squared minus 4. Once I do that, now, so originally they were not perfect squares, but once I factor out my GCF of 2, now I have 2 perfect squares. Okay, so the 2 stays there. Square root of 9 is 3. And of course the r is there. And square root of 4 is 2. So it's 3r plus 2, 3r minus 2. So don't forget to factor out that GCF. Another type of problem you may see, or you will see, 9xy squared minus 4x. Okay. They both have an x, so I know I have to factor out an x and factor out my GCF. In this case, it's just x. And I'm left with 9y squared minus a 4. So again, once I see that, I have my 2 perfect squares, so I know it's my special, or the factoring the difference of 2 squares. So I have my x. And then again, 9, square root of 9 is 3, square root of 4 is 2, so you just go 3y plus 2, 3y minus 2. And again, kind of a quick, I know there's not even a lot of problems on there. I'm probably doing an example of, almost doing every kind of example that you'll see, but this one here, be careful, because originally you look at it and you say, I have 2 perfect squares right there, I'm ready to factor. But we have to factor out, remember, our GCF first. And there's a greatest common factor in 116, and that is 4. So we want to factor out that 4 first, and then it's going to leave us with 2 perfect squares as well. This would give me 25 minus 4x squared. And now, if you notice on this one, Normally we have that exponent first, but in this case we have a number. It doesn't really matter how, it's not going to really change much. That square root of 25 is 5, square root of 4 is 2, and then we know that square root of x squared is just x, so this becomes 5 plus 2x, and then 5 minus 2x. All right, so some new stuff with factoring these binomials. Just again, I'll remind you guys, when it is a positive, that's where you would say it's prime. Just remember, you can't factor it unless you have the difference, again, the subtraction of two perfect squares.